All right, this is going to wrap up chapter 7 for us. So, we're going to talk about complex numbers. Now, complex numbers come from they're complex because they have two parts. They have a regular number part, which we uh, are the real numbers. And then we're going to see there's an imaginary part to the number, and those two parts together make a complex number. So, we're going to see what they are, and then we're going to learn how to add, subtract, multiply complex numbers. Okay. So where it comes from is if we take the square root of -1, that's what they just define that to be I. Now, when we first looked at this, we said that's a non-real number, and we just kind of brushed it off. We can't get a number this way, and the reason is because there is no number that when you take it by itself, a number times itself, that would give you a negative number. So we don't really know what I is, but we do know what I squared is. If we take I and we square it, we get -1. Why? Because we say we do. That's what's so cool about math. You just make it up and then it's true. You say it's true and it becomes true. Reality follows our vision. So I is some kind of a number that when we do square it, we get -1. It's not a negative number because a negative times a negative is positive. It's not a positive number because a positive times a positive is positive. Negative times a negative is positive. I think I said the other way. Anyway, I got myself confused. But I is such a number that when we take I times I, we get -1. And it exists because we say it does. Now, the cool thing about all of this is that imaginary numbers actually have an application in the real world. Even though it is completely made up, it's completely fantasy, it's imaginary, they actually have an application, and it comes for like your smartphones and all the technology we have. When you start making smaller and smaller chips with computer chips and stuff, and everything that's on them, they're so tightly packed, they actually use imaginary space to make those. Um, to get everything on there. And it actually works. Okay, so basically, all we got to remember is that I squared is a negative, and so when you have, and so that means that if you take the square root of a negative number, and this one, all we have to worry about is -1, it turns into I. So the way to think of this is that the square root of -a is square root of -1 times a is how we can kind of think of it, which is, remember, square root of -1 times the square root of a. And so we just call this I. And that's how they get this. So there's just, we don't need anything more than this single number. We don't need this. We don't need to know what the square root of -5 is, because we break it into the pieces. -1 goes off here, and then it's the square root of 5. You'll see how we'll do this with these. So it just gives us mostly what we've been dealing with in this class have been real numbers, and which are broken up in rational and irrational. Things like pi is irrational, so that's how those are. But now look at the numbers we're able to deal with. We deal with purely imaginaries, which basically all they have is an imaginary part, because again, a is 0, so really it's just some number times I. You get the other imaginary, not fully, where a doesn't have to be 0. So, and that's really what the complex numbers are. I'm not sure why I would have just pushed these up here, complex. Anyway, complex numbers have both a real part and an imaginary part that we add together. They are not like terms. Imaginary numbers are not real numbers, and real numbers are not imaginary numbers. So they're not like, and that's why we have to write them in this complex form. A real part and an imaginary part. Okay, so we can go through and write each of these. So this is like, again, square root of -1 times the square root of 36. Square root of 36 is 6. Square root of -1 is I. So a lot of times they move the I to the end, and that's how they're going to do it. Let me, and so, they just jump to it, or they put it in the front. What I'm also going to, and here they put it at the end. I'm going to show you, if you got the TI calculator, TI 85, 84, 83. If you go to the mode button, you can actually teach your calculator to do something. You can teach your calculator to do imaginary numbers. Let me show you right now. Let's come back here. Let's go with square root of -36. I don't think I have it set yet. So it tells me an error. It cannot, that I'm in real mode, so it can't calculate it. What we're going to do is we are going to switch over into imaginary mode. So down here, if you look along here, there's this where it says real, and then there's a plus bi, and then there's this one, which is polar coordinates or polar numbers. We won't even talk about those yet. So I arrowed down to real, I arrowed over, and now it's flashing on there. What I do is I hit enter, and now I've moved the calculator into complex mode. Okay. And the cool part about this, it doesn't affect anything that you would do in the real mode. If it's a real number is a complex number. So it's just added the addition of complex numbers. And now I'm going to get out of here, I go second quit. Notice quit is a mode shifted, so second quit. Now out of this, now watch what happens if I take the square root of negative 36. It now knows that that is 6i. Cool. I could do it with 15. Square root of negative 15. Again, 15 is not a perfect square, so it gives me this decimal equivalent I. Here, they're going to just leave it as square root of 15. So I square root of 15, and that's all they're going to say. Okay, square root of negative 45. Now that's 15 times 3, which is 9 times 5. So you're going to actually be able to break this down like we were doing earlier. Take the I out, so that gets rid of the negative, and then this can be 9 times 5. So, right, so you get square root of 9 times square root of 5. This part is 3, so it should be 3i square root of 5. Yeah, they break it there, 3i square root of 5. Okay. Now the calculator doesn't keep it as square root of 5, doesn't go into exact mode. I've never tried it. Let's see. Mode. There is sometimes a place where you can say answers auto or decimal. There's a place sometimes you can say exact mode. I don't see that here where it would actually give it in the square roots. Maybe it's a different calculator I'm thinking of. Anyway, this is what we'll do. Sum or difference of complex numbers. So basically just think of this is the real parts get added together, added or subtracted, the imaginary parts get added or subtracted. That's all that happens. So notice you have to add like terms, so a plus c, or subtract like terms, a minus c. And then the imaginary parts, bi plus di, and so you add. It's just thinking of it as what if you had bx plus dx, that would be b plus dx, right? Like that. Okay, so it really just acts like a variable. So here we're going to get a negative 3 on the real part, right? Because you're combining like terms, and then you'll get plus 6, 7, 8. You'll get an 8i on this part, and you'll get a negative 3 on the real part. But here's the thing is when you are in real mode, watch this. We can actually do this. We'll do parentheses negative 8 plus 2. And now look at on the decimal, there is the I. So the I is shifted. We go second decimal point. There's our I. That's what I like about this. This whole unit pretty much can be done with the graphing calculator. Desmos doesn't do these type of functions, at least not that I'm aware of. But as long as you enter it in, watch, it's going to do the calculation negative 3 plus 8i. And let's watch them go through. Add like terms, negative 3 plus 8i. Same thing over here. The calculator can do it. Let's come here, right? Just go over here. So we've got 9i minus parentheses 3 minus 2i. And when you go think about this, negative is going to distribute, so that 2 is going to be positive. 2 and 9 are 11i, and then a minus 3. So minus 3 plus 11i. Seems reasonable, and that's exactly what it's doing. It's doing like terms. So the calculator can handle it, or you can do it by hand, however you like. And again, it depends upon whether you have the graphing calculator or not. And it will be of great help for you for those taking college algebra. It is a little bit of help in college math, a 141 or 142 course, but definitely if you're taking college algebra, you'll want to have one because it's just going to be valuable for you. Multiplying out, again, the cool part is with the graphing calculator, back over here, we just put it in exactly as it is. And what you'll see is basically we're going to be foiling that out. But this one, you just type it in. And it's 18 plus 6i. Let's watch how they get it. It's a few more steps over here. So we're FOIL. So we're going to get 6 times 2 and then 6 times 2i. 6 times 2, 6 times 2i. Minus 3i times 2 and minus 3i times 2i. So we had to, distribute here. This and this, this and this. So we multiplied everything out. This is going to give us, so we get this becomes 12, this is 12i, this is 6i, and this becomes 6i squared. And then remember, this is where we're going to apply I squared is actually equal to -1. Come on. There we go. I squared equals -1, so that makes it a positive 6. 6 plus 12 is 18, and 12 minus 6i, they're like terms, there's plus 6i. But again, that's what we got right from the calculator, right from the bat. Just enter it in, boom, done. This one, same thing, we can multiply it out using FOIL. Again, you're going to get here we go, 6 times -7, 6 times 6, I guess that's what they do first, and then 7 times 6, that's that one. You could kind of see here's a minus, there's a plus, there's a minus and a plus, so this middle term is going to go away. So this is also called a conjugate. They're going to use that later. We're not going to take a look at that. We're not going to worry about that in this setting. Okay, so we get 36 minus 49i squared. Remember, this I squared becomes -1. It's going to make it a positive, and there we have it. And then we add these together, so we end up with 85. The calculator would have done the same thing. And that's the lesson for tonight. So use the TI calculator, very good resource for this. Or treat the I. All you really need to know about I is when you square it, you get -1, and that the square root of -1 is what I is equal to I, and just sort of follow like terms procedures, and you can add, subtract, and multiply them. I didn't go into the section on division because I'm not going to have you work through those. We don't really need to. That's enough with imaginaries. It gets us to where we need to be, and we'll keep moving forward. Take care, be well, and keep making great progress.